9 parts of a substance. If man can have a complete control over nature, if nanotechnology is being completely understood. In general terms, if I say what is nanotechnology, it's simply a hybrid science combining engineering, chemistry, and to a certain extent biology. Now, as millions of these atoms are pieced together by nanomachines results into nanoparticles. Now, think is how these nanoparticles are being obtained. Current research has shown there are two ways how these nanoparticles can be obtained. These two approaches are, first is the top-down approach, the second one is bottom-up approach. First of all, top-down. It simply indicates the reduction of larger substances by physical methods down to a nanosize. And the second one is bottom-up. In this, we start with the bottom stage, simply deal with atoms and molecules, combining them together to get the nanoscience particles. The next we have structures of nanomaterials. We have two structures. The first one is nanotubes, the second one is nanowires. We will be discussing them very briefly. First of all, what are nanotubes? Nanotubes are simply tiny tubes of carbon atoms about 10,000 times smaller than human hair. Now we have simply broader sheets of monolayers and multi-layer carbon atoms. These can be metallic, these can be semiconductors, depending upon the way carbon layer is being rolled up. Considering this being the carbon layer. Now, if this carbon layer is being rolled like a cigarette, means this being the edge, if it's being rolled along its length, then the nanotube which you obtain is what is termed as metallic nanotube. Second one we have semiconductor. If this carbon tube is being rolled like a straw, means like this, having a gap in between, then the nanotube which we obtain is what is termed as semiconductor nanotube. Then we are having nanowires. Nanowires are simply wires having a nano sign, stands for minus nano sign. They can be metallic, semiconductor, insulator, depending upon the material from which they are being made. Then they can be used to build next-generation computers, electronic devices of a nano. Now we are having applications of nanotechnology. We have so many applications of nanotechnology. My basic research work I have done upon quantum dots, but briefly what are smart clothing? In smart clothing, what we are having in a cloth itself, we are having sensors and computers to get a better quality clothes resistant to environmental changes. Then we are having environment. If nanotechnology is completely understood, we can have a pollution-free environment, and we can even add an ozone layer to the environment, which is nanoparticles. Then we are having supercomputers. We can have very fast and very small nano-sized computers. Now, basic, that is quantum dot. Now consider this being the size of a semiconductor material. Now, if I have reduced this size to this much, then that nano-sized semiconductor material is what is termed as quantum dot. Now, the usefulness of quantum dots comes from the speed emission, frequencies, extreme sensitivity to both dot size and computation. Now, the question lies is why quantum dots are so sensitive towards dot size and composition. To understand this, the very basic terms every one of you are aware, so I would like to skip it. So basically, we have valence bands, conduction bands, electrons, and holes. All are familiar with this. Now, the concept of valence bands, conduction bands, electron holes, as they apply to the semiconductor material, it same applies to the quantum dot. But there lies a major difference. The major difference lies in the fact of exciton Bohr rate. Now, what is exciton Bohr rate? The electron jump from valence band to conduction band. A physical gap is being created. This physical gap. Now, this physical gap is what is termed as exciton Bohr rate. Now, when we are having semiconductor material of this much size, exciton Bohr radius is of this much. Means exciton Bohr radius is much smaller as compared to the actual size of semiconductor material. But when we have reduced the size of semiconductor material to nano-sized particle, what happens? The size of nanoparticle is same as that of exciton Bohr radius. In that particular case, the energy levels are no longer behave as a continuous level, but they behave as a discrete energy level. And this is the basic reason that why quantum dots are so sensitive toward their dot size and exhibit various properties as their size changes. So here I have shown the same. As the size increases, size of quantum dots increases, different colors they are emitting just because of this very reason I have explained. Then we are having advantages of nanotechnology. It's been inexpensive, no labor cost, very less packaging cost, along with very less material is being required. Then we are having energy efficient, obviously, no energy is being lost with nanotechnology. Then we are having resource efficient. You must believe that with the help of nanotechnology, we can have a diamond just from coal material by simply rearranging the atoms or particles of coal. We can have food just from heap of garbage by simply rearranging the elements, atoms of a garbage. So these are the various advantages. Then we are having disadvantages too. First of all, with this we are having various ethical and moral issues. Many people believe since with nanotechnology there will be very less cost, there will be very less labor, there won't be wages to be paid to people. That's why it's considered ethically and morally wrong. Then it could be used nanotechnology can be used like people can use for nuclear bombs, nuclear weapons. Then there can be nanoparticles could be dangerous to humans as well as to animals. Then at the end is conclusion. Nanotechnology offers the ability to build large numbers of products that are incredibly powerful. This responsibility creates both opportunities and risks. Still, some laws should be set for its proper use. This technology is really a boon to mankind. It is a better. Now, how to use and when to use